Hello student, welcome to online tutorial session. So the concept of algorithm and the concept of a flowchart is, I hope, and clear, and the symbol as well, it is clear. So you have to learn this meaning of the symbol carefully, because while we are drawing this flowchart you have to remember what is the function of which function, what is the function of this particular symbols. Okay, so today we will learn about the different assignment operators are basically we are using a relational operator, mathematical operator, logical operator that actually is there. Okay, so the language you use to write algorithm is to be in simple manner and similar to day-to-life language. The variable names are used to store values. The values are stored in a variable can change its solution step. In addition, some symbols are actually required. This is the assignment symbols. Equals to are there. That is arrow symbol is there. Okay, so I can write that a equals to 5 in this way also, or I can write a arrow in this one. So both are represent the assignment. It means I am assigning the value 5 to A, or assigning the value 10 to B, or 10 to height, like this. Both are represent the same thing. This is a representation of a assignment. Okay, now coming to the topic, that is a mathematical operators. You know, in the normal algebra also, in the Boolean algebra also, you have learned this type of mathematical operator, that is plus. This is, you can say, you can represent as a plus b, like this. Okay, then the subtraction, like this one also can be representation. Then there is a multiplication. Okay, then there is a division as well. Okay, another one is the power. You can give a cap value. It means to the power 1. So directly you can write a cap 3, or you can directly write a cube. Okay, in this way. And one another operation is there, that is known as the remainder one. Okay, so remainder is one is what it is very important. In few cases we require this remainder operator. Okay, when we are checking the remainder is exist or not in few cases. So remainder operators are like this. So it means we are checking that while we performing the division, any remainder is there. If remainder is there, it means it is not particularly divisible. If remainder is 0, it means that it is perfectly divisible. It is divisible. If it is not 0, apart from any one value 1, 2, 3, so we can write and it is not divisible. So few cases we need to check the remainder value. In few algorithms it is required. So that's why this mathematical operator is also we are using. I hope the mathematical operator part is clear. Now we are moving to the another part, that is the relational operator part. This also you have learned in the Boolean algebra part as well. That is, so less than. This is the symbol of less than. So we can write down A is less than B or not, or less than equals to or not. Less than equals to, I am writing this one. Next is greater than. So I am writing A greater than B or not, or A can be greater or can be equals. In the both the condition I can write down. Okay, and another one is there, that is the not equals to. Not equals to can be represented in both the way, in or either this way or in the this way, or you can write it is a not equals to, or you can give in a hashtag b. Generally we are using this convention only. Okay, a not equals to b, and greater than equals to. Okay, and another one is there, equals to is also there. This is equal or not. So this kind of represent is a equals to b. So checking the equality between the two operators also. This is all the relational operator and the mathematical operator we are able to find in this flowchart, or we are using in this. Okay. Now we are moving to this another operators, that is the logical operators. It's very very important. So logical means what kind of a logic we are using? We are using the AND logic. AND logic, it means AND logic is there, OR logic is there, and NOT logic is there. Okay. So AND means, that is, okay, one by one I am explaining. First I am explaining the AND condition. Okay. So AND condition says, suppose this is a condition, it is A less than B and B less than C. If this condition need to be true and this condition is need to be true, because AND means what is a multiplication. If the both the value are true, then only we are getting true as a value. If you both the value as 1, in case of AND gate, think about the logic diagram. If 1 in this, in both the input is 1, then only we are getting the output as 1. So it is says that if the both the conditions are true, then only whatever steps is written under this condition is need to be followed. A must be less than B and B must be greater than C. If this condition is true, then only whatever steps we need to execute that. If it is a AND condition, suppose we are doing the OR operation. Okay, so OR, if we are doing OR operation, then what will happen? So if any of this operation can true, either one. So if you remember the OR gate truth table, so if 0 is there, then only we are getting 0. In the rest of the cases, whenever there is a single one input is there, or both the input is at 1, then we are getting the output as a 1. So wherever, if either of us are true, we can accept. If maybe this condition is true and this condition is false, or maybe this condition is false and this condition can be true. If either of these two conditions, any one is satisfied, it means any one is true, then only this whatever steps is under this is written need to be followed. Okay. Now coming to the next, that is the NOT operation. Okay. NOT operation. NOT operation says that is not A less than B. Okay, so not A less than B, it represents what? That is this result I am checking, that if this is the result is true, then or else this one is false. Not this one. Not just the opposite of this one. Okay, not this. A not greater than B. Okay, these things I am checking. Okay. Now currently there is a selection controls are there. There is a actually control statement and loop statements are also present is over here. So what are those? The loop statement and the control statements is there. There is a if condition is there. So under control statement there is a if option is there. If the condition, this is the condition. Okay, we are checking. If this, then what you have to do? Then we have to perform something. Then end if this condition is closed. Okay. So if certain criteria I am giving, if this criteria is true, then only we are moving to execute the statement, and after that, after the execution, it will be end. Another criteria can be there, if then else. Okay, end if not occur, that they are checking if this is the condition, then do that, or if this condition is, if condition is false, then do the else part, whatever written in the else part, then the condition is closed. If this condition is true, then execute whatever statements written under this. If this condition is false, then comes to the else part. Whatever written over here, that will be executed. After execution of any one of the statement, when the execution is finished, then end this condition. Okay. So this is how we are doing the selection condition. Now coming to the loop control statement. Loop control, when we loop is required, when actually you know the number of steps are required to getting your result. You know that after fifth number of cycles you will get, if you repeat this term or step 5 number of time or 10 number of time, then only you are getting the output. So whenever you know this kind of a number of steps, then only you can use this loop condition. Okay, so the first loop condition, it is while do while loop is there. While is there, while there is a condition is there. Okay, while this condition and do these things. Okay, while there is a condition, if it is satisfied, then you do this kind of a condition, and then end do. It means whenever the execution is end of this statement, then end, you end that particular path. Okay, now coming to the another part, that is one while loop we have there, and do until loop. Okay, do until loop, it means that under do part, whatever conditions are there, you are keep on checking. Do this until, okay, here condition will not check at the first. Do this to this to this until this condition satisfied. Okay, until this condition is satisfied, whatever condition is satisfied, until this condition is satisfied, until you have to continue. Whenever this satisfied, you overlook that one. So execute the loop as long as the condition is false. We have to execute this test until this condition is false. Okay, so this is the loop part. Another one is the go to statement is there. Okay, so go to statement is working. This is a very common one. Go to statement is also called the unconditional transfer of a control statement. It is used to transfer control of a execution to one step to another step. It's go to step number n, go to step 2. Okay, so like whatever after execution we are continuing, we stop the execution and jumping to the step 2, step 1, whatever lines number it is mentioned. Okay, I hope up to this it is clear. Thank you student, I am ending my lecture over here.